Hello everyone. In this video, we are going to discuss about the operations on sets. Specifically, we will be discussing about union of sets of chapter 1 set class 11 max. See, we will be discussing about the other operations like intersection of sets, difference of sets, etc. in the coming videos, which will be available in the playlist. So let us talk about the operations on sets. See, we are familiar with the operations of addition, subtraction, multiplication and division on a pair of numbers to get another number. For example, when you add 5 and 13, you will be getting 18. This is a kind of operation. Similarly, when you multiply 5 and 13, you will be getting 16. That is also another kind of operation. Similarly, there are some operations performed on two sets. Here the operation addition, multiplication, or you can consider subtraction, division, they are actually performed on two different numbers, a pair of numbers to get another number. Similarly, there are some operations performed on two sets which give rise to another set. So union of sets, which is represented like this is actually a kind of operations on set. So in this video, we will be talking about this union of sets. See, the union of sets A and B. That is, we are considering two sets. One is A, another one is B. The union of sets A and B, it is a set which consists of all the elements of A and all the elements of B, but the common elements are not being, common elements are being taken only once. They are not repeated. That is, union of two sets A and B, that is actually written like this, A union B. Okay, this symbol denote union. So, A union B. Let us see one example for the union of sets. Consider one set A. This contains 2, 4, 6, 8. Another set B is here. It has these elements 6, 8, 10, 12 in it. Now, if you find out A union B, okay, you will be getting a new set. You will be getting a new set which consists of all the elements of A. So, all the elements of A must be written here. So, 2, 4, 6, 8. And A union B consists of all the elements of B. So, all the elements of B also must be written here. But the common elements are being taken only once. So, you see, when we consider the elements of set B, 6 is already written. So, no need to write it again. 8 is already written. So, no need to write it again. Now, we have 10, then 12. So, this is a new set which is equal to A union B. Now, if you consider another set A which has these elements in is A, E, I, O, U. Another set B which has these elements A, I, U. Okay, here you see all the elements of set B, A, I, U are already there in set A. So, we can say that B is a subset of A. Alright, now if we find out A union B, see, we have to write all the elements of A. So, A, E, I, O, U, and we have to write all the elements of B as well. But the common elements are taken only once. No need to write it again. So, when we consider the elements of B, A is already written here. No need to write it again. I is already written here. No need to write it again. U is already written here. So, no need to write it again. Okay. So, this is the set which is equal to A union B. And you see, this set is actually equal to the set A, no? So, this is actually set A. That is, if B is a subset of A, then A union B will be equal to A. If B is a subset of A, then A union B will be equal to A. Now, let us see this union of two sets A and B. It is, defined in the set builder form. Here you see A union B can be written as set of all x such that x belongs to A or x belongs to B. That is, set of all x such that x belongs to A or x belongs to B. That is, all elements in the new set A union B are either in A or in B including those which are in both. Okay, so the elements in A will be there in this A union B. Elements in B will be there in A union B. And the elements which are common in both, that also will be there. But no need to repeat the numbers or the elements again and again. Now, let us see the Venn diagram representation of union of two sets A and B. See, when we consider A union B, that is, we are discussing about the Venn diagram representation of A union B. So, this A union B, this actually includes all the elements in A and B. Okay, you see, all the elements in A must be there in A union B, all the elements in B must be there in A union B, and there can be some common elements present in both the sets A and B, that also will be there in A union B. So in Venn diagram representation, we will represent it like this. Let this be the set A, alright, and let this be the set B. Then A union B, no? We have to consider all the elements in A. So all the elements in A must be considered. And we have to consider all the elements in B. So all the elements in B must be considered. Okay, and there can be some elements present in both A and B, that also must be considered. So this intersection, no, this section actually indicates this one. This actually indicates the elements, the portion of the elements which are present both in A and B. So this is how the A union B is represented in Venn diagram representation. Now let us see some properties of the operation of union. The first property is A union B, that is equal to B union A. This is actually known as commutative law. So this is the first property for the union of two sets. A union B is equal to B union A. This is actually known as commutative law. Let us see one example for that. Let us consider a set A which is equal to 1, 2, 3. Now let us consider another set B which is 4, 5, 6. And let us consider another set C which is equal to 7, 8, 9. Alright, now here you see, if you consider A union B, that will be equal to what? We have to write all the elements in A. So 1, 2, 3. We have to write all the elements in B. So 4, 5, 6. Common elements are written only once. Here no common elements. Alright, so this is A union B. Now let us write B union A. So we have to write all the elements in set B. So 4, 5, 6. We have to write all the elements of A. So 1, 2, 3. So you see, here all the elements in set A union B, that is actually equal to all the elements in set B union A, no? The order has no relevance in writing this form. Okay, listing the elements, the order of listing the elements is not relevant, not important. So you see all the elements are present in both the sets are the same. That is here A union B, that is equal to B union A. That is what commutative law states. Now let us see the second property of the operation of union. That is A union B union C is equal to A union B union C. This is actually known as associative law. So let us consider three sets. A equals 1, 2, 3, B is equal to 4, 5, 6 and C is equal to 7, 8, 9. So let us see whether it is a true statement or not. So what about A union B? A union B will be equal to, we have to write all the elements in A and we have to write all the elements in B. So this is A union B. Now let us find A union B union C. That is the left side. Okay, so this will be equal to what? A union B is this one, C is this one. So when we write the union, A union B, this set, union this set. So when we take the operation union, we have to write all the elements in A union B. That is 1, 2, 3, 4, 5, 6. And we have to write all the elements in set C. So 7, 8, 9. So this is A union B union C. Now let us see what is B union C. Alright. So B union C, that is, we have to write all the elements in set B. So 4, 5, 6. And we have to write all the elements in set C. So 7, 8, 9. So this is B union C. Now what about A union B union C? That is, we are taking the operation union on these two sets. One is A, another one is B union C. So A union B union C, we have to write all the elements in set A. That is 1, 2, 3. We have to write all the elements in this set B union C. That is 4, 5, 6, 7, 8, 9. Okay, now you see, this is A union B union C. This is A union B union C. You see, the results are the same now. All the elements in this set, that is actually the same as all the elements in this set. Alright, so here we can write A union B union C. Okay, that is actually equal to A union B union C. This is actually known as associative law. Now, let us see the third property of the operation of union. That is A union phi. Phi is the null set. That will be equal to A. This is actually known as law of identity element. Here you see the null set phi, that is actually the identity of the operation union. So here you see phi is actually the null set. No elements will be there in that set. We have already discussed about null set in our previous video. Now what about A union phi? So here you see A is set 1, 2, 3. So A union phi, you have to write all the elements of set A. So 1, 2, 3 and all the elements of set phi. No element is here. So this is A union phi. This is actually equal to what? You see 1, 2, 3, that is A. Alright. Now let us see the fourth property of operation of union. That is A union A is equal to A. That is actually known as idempotent law. That is, here A is equal to 1, 2, 3. So A union A union A. So you have to write all the elements in A. That is 1, 2, 3. You have to write all the elements of this A. That is the same 1, 2, 3. No need to repeat the elements again. So this is actually equal to what? A. Okay, so A union A is equal to A, which is known as idempotent law. Now let us see the fifth property. That is, U is the universal set. So U union A, that will be equal to U. This is actually known as law of U, which is the law of universal set. That is, for example, let U, the universal set U be 1, 2, 3, 4, 5, 6, 7, 8, 9. We have the set A as 1, 2, 3 here. The elements are 1, 2, 3. So what about universal set U union the set A? You have to write all the elements of the universal set. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have to write all the elements of set A, which is 1, 2, 3 once written. So no need to write it again. Alright, so you see U union A, that is same as the universal set U. Okay, so this is equal to U. And this is known as law of universal set. So in this video, we have discussed about the operations on sets, specifically the union of sets. We will be discussing about the intersection of sets, difference of sets, etc. in the coming videos. I hope this is clear to you. I hope it is clear to you, the union of sets. Thank you.